dark sky site recently, and it was great to be up there. We are opening it up very shortly, and we have our Christmas party coming up in the not too distant future. And we look forward to welcoming many of you back up there again. So I'll introduce Isabel Romero Shaw. She is a graduate astrophysicist into gravitational waves and based at Monash University. So she studies the ripples in space-time that emanate from collisions between black holes and other such large things. This happens the other side of the universe and often happened millions of years ago. We are now detecting more and more gravitational waves, far more than anyone ever expected. But as well as this ancient space history, Isabel's interested in ancient Earth history, much younger stuff, and particularly interested in the relationship that ancient humans had with our night sky. She recently published a children's book, How the Night Sky Has Affected Human Language. So in this brief talk, she'll start talking about the names and of our planets. Now, we've all heard jokes about Uranus. It sounds much better if we pronounce it Urinos. It doesn't bring the same form of jokes about. But please don't send them to us. We've heard them all before. It was originally going to be put forward to be called George, which, after a king of England, someone was after a handout even in those days. Pork barrelling isn't new. So we've wondered about how the planets get their names, whether their true characters are anything like their mythological namesakes. This talk is for you. It'll teach you a lot about our solar system. So she'll introduce the language the first humans in Europe used, explaining these primitive roots involved into the names we use today. She'll also introduce you to the intriguing origins of some of our other space-based terms like galaxy, telescope, even universe. So without further ado, I'll over to you, Isabel. Welcome to our society.
Thank you very much. That was a really great introduction. So yeah, hello everyone, I'm Isabel, and as I've just been introduced as, I'm a PhD student studying gravitational wave astrophysics at Monash University. If you have questions about that, I'm happy to answer questions about those at the end as well. And I've written just about in brackets on this slide because I'm hoping to submit my thesis on Friday, so I am really just about to cross the finish line. But today I am going to be deviating from my usual topic of study to tell you about something that I've been getting interested in recently, which is etymology, also known as the study of the origin and evolution of words. So this is as a group. Okay, so as I just mentioned, I am an astrophysicist. I'm also originally from the city of Bath in the UK. This is a photograph of the Bath Abbey that I took when I went home to visit a couple of years ago at Christmas in 2019, before the world shut down and everything went mad. But so now I actually study at Monash University, which is in Australia, as I'm sure you know. And here is a picture of some of the Australian animals that I've met here. So this is a young kangaroo and also a paddy melon. Didn't know anything about paddy melons until I moved here. They are the cutest thing I've ever seen in my life. And I met this one in Tasmania. So since I actually study astrophysics in my day job, I've chosen to give this talk on the etymology of the universe, or as I like to think of it, About words. Anyway, the problem with studying the origin of words is that we use words all the time. So once you start thinking about where they come from, it's kind of hard to stop. So in the course of researching for this presentation, I found myself going on lots of deep dives into words that are not even related to astronomy. So to give you an idea of how interesting everyday words can be, let's dive into where some of the words on this slide come from. So the word etymology comes from the Greek words for original meaning and the study of. So you can probably think of lots of words that end with ology, like biology, neurology, epidemiology, virology. We've heard about those recently, that all refer to different fields of study. And we can also look at the etymologies of names. So my first name, Isabel, is the Scottish version of the Spanish Isabel, with an A, which evolved from the medieval name Elizabeth and has its roots in the Hebrew name Elisheba, meaning God is my oath. So the first half of my last name is a Spanish or Italian surname, meaning something like coming from Rome. So it might have referred to somebody who actually was from Rome or somebody who had been there on a pilgrimage. And the last name in my name is Scottish and stems from the Old English word for copse or thicket, and is a name that would have been given to somebody who lived near the woods. So in its entirety, my name means something like God-fearing woman from Rome who lives near the woods, which is not a very accurate description of an atheist from England who lives in suburban Melbourne. But we get what we're given. So after I'd thought about the word etymology and also my own name, I started thinking about my job description. So the word astrophysicist can be split into two parts, with the first part, astro, coming from the Greek aster, meaning a star. This in itself stems from a word that is something like stir, which is the Proto-Indo-European word for star. So this term, Proto-Indo-European, will come up a few times in this talk. So I better go over what it means. So back in the late Neolithic and early Bronze Ages, the Proto-Indo-European people are thought to have lived somewhere in what is around somewhere that is now modern-day Ukraine. They then spread out to Europe and India, taking with them one common language, Proto-Indo-European, that then grew and evolved into the many European and Indian languages that we have today. For example, the English word hundred, which shares this Proto-Indo-European root with loads of other languages. So just to warn you that this slide is about to fill up with words. I don't expect you to read them all. It's more illustrative than informative. So the word hundred evolved through a number of stages into all of these modern words for hundred that we recognize today. So the English word for hundred is up here in the top left. So the way that we get this kind of word map is by kind of mapping the evolution of words, and professional etymologists who are all experts in the way that words evolve look for ways to link all of the modern day words for things back to their kind of one common source by tracing through literature and records and that kind of thing. So for example, going back to the word astrophysics, the second half, physics, can be traced through its Latin and Greek evolution as physica, meaning natural things, back to its more primitive roots as a word related to making things grow, like a farmer might. And the natural things was also the name of Aristotle's treatise on nature, interestingly. The word student can be traced back to a Proto-Indo-European word meaning to push or to beat, which brings up some nice imagery of kind of beating knowledge into your brain as you study, which is certainly how I feel in this last week of my thesis. But what about the word universe? Well, we're actually going to build up to this over the course of this talk, but for now, let's start our exploration of the word universe from the very place that all of our explorations of the universe have begun, which is on the planet Earth. So the Earth wasn't always thought of as an astrophysical entity, which explains why our word for the Earth is the same as our word for the ground or the soil. This is how humans have known the Earth for most of their evolution, as the soil that allows them to grow food and survive. There are Other words for figures that have been goddesses of the earth or guardians of the soil and agriculture, like the Roman Tara, the Greek Gaia, and the Norse god Jord. So these are roots of some words that relate to the earth today. For example, the word terrestrial for something that comes from the earth, and geology for the study of the earth's substance. So if we just talk a little bit about how we've understood the Earth's place in the universe over our kind of history, Earth was recognized as spherical by the end of the 5th century BC by Greek intellectuals, but it was believed to be the center of the universe until the 16th century. Before the 19th century, it was widely believed that the Earth was only a couple of thousands of years old, but in the 19th century, geologists proved that it's actually billions of years old. And way before we recognized Earth as a planet, we did notice that we seemed to have some relatively nearby neighbors that differed from the background stars that we saw in the night sky. For example, one very obvious one is the sun. So the sun has always been seen as extremely important in human civilization, largely because the sun has been seen to dictate day and night, as well as the seasons, which would lead into when you could sow your crops and harvest them, and everything by which kind of primitive humans would have lived their lives. So the Proto-Indo-European root of the word sun also evolved to another familiar word for things relating to the sun, which is sol. And we use the word sol for things like the solar eclipse and the solar system. Sol was also the name of the Roman god of the sun, Sol Invictus, or the unconquered sun, who would ride across the sky in his golden chariot. Another object that was very important to early humans was our moon. So our word for moon stems from a Proto-Indo-European word that meant month, as well as the measuring moon, because we could use the moon changing from a full moon to almost invisible and back again every 30-ish days, and would use that to measure the month. In fact, the very word measure itself is linked to the word menses, which was the Proto-Indo-European word for the moon. Although there was also another word that they used for the moon, this was a completely different word, and this meant the kind of shining moon. And this word evolved into the Latin Luna, the name of the Roman moon goddess, who was the sister of Sol Invictus. So this word is also the root of many of the words that we use to talk about things relating to the moon, like the lunar eclipse. So another thing that people noticed very early on was that some of the stars in the sky move differently to others. While most stars appeared to move very slowly due to the rotation of the Earth and also the Earth's movement around the sun, some appeared to move much faster or in different directions, so not following the crowd. The word planet can be traced back to its Proto-Indo-European root. It can't be traced back to its Proto-Indo-European root, but the ancient Greek name for wandering stars evolved into our modern-day word planet. So from Earth, we can see 5 planets with the naked eye. Those are Mercury, Venus, Mars, Jupiter, and Saturn. And each of these names have names that derive from the names of Roman gods. So to start, we have Mercury, who is named after Mercurius, the Roman god of travel, tricks, and commerce, who was also a messenger god and could travel very fast. And this is because Mercury looks like it moves very quickly across the sky. As a kind of an aside, this is also why the metal that we use in thermometers, or used to use in thermometers, was called mercury or quicksilver. As a metal that is liquid at room temperature, it appears to be relatively fast moving. Mercurius's equivalents were the Greek Hermes and the Norse god Loki. And the name Mercurius derives from the Latin name merx, originally from Proto-Italic merc, which was used to refer to goods and merchandise. And this is also where we get words like merchant and market. So another planet that we could see clearly in the night sky, and that we can still see clearly in the night sky, is Venus, which is the brightest planet in the sky, and was hence named after the Roman goddess of love and beauty. The word Venus was the Latin word for romantic love and desire, stemming from the Proto-Indo-European word meaning to strive for love. And interestingly, this root word is also the root word for words relating to things like winning or friendship or love, but also hunting, which is interesting. And it's also linked to words like Oh, sorry. And it's also linked to words like venom and wine. The Roman goddess Venus, who was famously very beautiful, was married to Vulcan, the god of fire and the forge, who was notoriously a very ugly god. Actually, perhaps Venus should have been named Vulcan, since we now know that the surface of Venus is completely inhospitable to life and is covered in volcanoes. So people once thought that Venus would be a great place to go on holiday from Earth. It's almost exactly the same size as Earth. It's a rocky planet. It has an atmosphere like we do. And since it's a little bit closer to the sun, people thought that it would just be a very nice and warm holiday destination. But it turns out that Venus is not friendly at all. Although it's the second planet from the sun, Venus is the hottest planet because it has a very thick atmosphere that acts like a big coat, letting the sun's heat in but not letting it out again. The average temperature on Venus is 465 degrees Celsius, pretty toasty. And to make things worse, its thick clouds are full of acid, and the atmosphere is so heavy that you'd be flattened to a pancake on its surface. So really not the best holiday destination in the end. The next planet, Mars, appears to have a distinctly red hue in the sky, so it was named after the Roman god of war. So there's been a god of war or an embodiment of war for as far back as I could trace. And the name Mars stems from an Oscan word, mammers, which also related to a war god. So Oscan is a extinct Proto-Italic language native to southern Italy, which is known from inscriptions dating back as far as the 5th century BC. And the later Latin word for Mars, mavors, is linked to words for to cut, to turn, and also male. Mars itself has 2 small moons, which were discovered much later in the 19th century when we had telescopes. And these 2 small moons were named after the chariot horses of the Greek god of war, Ares. So these are Phobos, which means panic or fear, and Deimos, which means terror or dread. So really lovely names. But although it's named after a war god, Mars is not actually that scary of a place. As you probably know, we've sent rovers to Mars to help us work out how humans might be able to survive there in the future. Elon Musk is definitely very keen to get everyone to Mars. And if we can work out how people might get to Mars and how we might be able to survive there, then Mars might well be the next planet in our solar system that humans actually end up living on, which would be very exciting. Another planet that the Romans could see was Jupiter, which was the largest planet they could see, and who they named after their king of gods, who was also called Jupiter. The equivalent Greek god to Jupiter is Zeus, and they actually have the same Indo-European root word meaning bright day sky or heaven. And the other half of Jupiter stems from the Proto-Italic word for father, meaning that the whole word itself means sky father, which I think is quite nice. And the word for father itself comes from the Proto-Indo-European word for protector or shepherd, which is also quite nice. Jupiter has 79 known moons, although the Romans didn't know about them. There are 4 moons that are often highlighted as the Galilean moons, because they are the moons that Galileo first spotted in the year 1610 when he started using a telescope to observe them. But they were actually observed by a German astronomer named Simon Marius, slightly before Galileo spotted them. And Simon Marius actually gave them their names, which are Io, Callisto, Europa, and Ganymede. So these names were given to those 4 moons because Io, Callisto, Europa, and Ganymede were all kind of friends or lovers of Jupiter or Zeus in Greek mythology. Ganymede is actually a very interesting moon because it's thought to have vast saltwater oceans lurking under its crust, so it might be a candidate for a moon that could harbor life. And it's also the biggest known moon in the solar system, and in fact Ganymede is bigger than Mercury. So in these myths, Ganymede was actually a mortal man who was known as the most beautiful of the mortals, and Zeus chose Ganymede to be his cupbearer on Mount Olympus. The 5th planet that could be seen with the naked eye was Saturn. Saturn was the slowest planet to cross the sky, which might be why it was named after the Roman god of time, Saturnus, equivalent to Greek Kronos. So Saturnus was seen as an old man, actually the father of Jupiter. So Saturn, there we go. Saturn was also the god of agriculture. His name stems from the Latin satis, meaning sufficient or plenty, basically satisfied, which obviously shares the same root word. Saturn is famous for its beautiful rings, which look very, very thin and soft from Earth, but are actually made out of millions of chunks of ice and rock, from tiny pebbles the size of your nose to big chunks the size of your house. And although they look very thin from Earth, Saturn's rings are actually about 200 meters tall. But as well as its rings, Saturn has 82 moons, 82 known moons, might be more, which are named after other Titans. In fact, there is one enormous moon named Titan, which, like Ganymede, is bigger than Mercury, but it is not quite as big as Ganymede. So just having 5 planets in the sky was all well and good until the 18th century, when along came William Herschel and his telescope and discovered a new planet. So by the way, the word telescope can be traced back to Greek and essentially means I look at something far away. This word was coined in 1611 at a banquet where one of Galileo Galilei's instruments was presented. Anyway, Herschel's discovery of Uranus is particularly interesting to me because Herschel was living in my hometown of Bath when he made this discovery. He lived in Bath with his sister Caroline, pictured here making him a cup of tea while he polishes a telescope mirror. So Caroline worked as Herschel's assistant, and King George, you might see where this is going, King George III paid Caroline £50 a year for this role, making her the first woman to be given a salary as an astronomer. So Caroline made many discoveries in her own right, mostly of comets. And the word comet stems from the Greek word meaning long-haired, referencing the long tail of the star, of a shooting star. Related to this, the word asteroid stems from the Greek for star-like. But anyway, back to Herschel's discovery. Herschel actually wanted to call the new planet Georgium Sidus, or George's star, which was after the king at the time, but this name did not stick, largely because the French at the time hated King George so much that they just wouldn't call it that. And eventually the name Uranus was proposed, and since it was thought to be in keeping with the other planets, which were also named after ancient deities, this name did stick. Uranus was a Greek god, though, not a Roman god, which is kind of annoying to those of us who like everything to just have one consistent theme. But there you go. Maybe we can have a chat after the talk about what we think Uranus should have actually been called. But Uranus was the ancient Greek king of the sky, who was actually thought to be the sky, and was married to Gaia, who was the Greek embodiment and goddess of the earth. And this name stems from the Indo-European root meaning to rain, making Uranus the rainmaker. So when people were talking about what to call Herschel's new planet, they actually also proposed the name of the Roman god of the ocean, Neptune. And luckily, about 50 years later, another big blue planet was found. Very convenient. So they could call this one Neptune. And this next planet was discovered by a telescope as well. It was named after the Roman god of the sea due to its very bright blue color. The etymology of the name Neptune is widely disputed and unclear. It has links to words like nuptus, meaning veiled, and related to words like nuptial, potentially relating to the marriage of the sky and the sea. It's also linked to an Indo-European word meaning damp or fog, which is linked to the word neptu, meaning something that is moist. Given the adjectival form neptuno, it means he who is moist, and neptuno sounds a lot like Neptune. However, the word is also linked to the root of the word nephew, which is linked to various stories and myths where a sea deity is born out of the waves. So we don't really know where Neptune comes from at the moment. And finally, for the planets, I've got to talk about everyone's favorite non-planet, Pluto. So Pluto was discovered in 1930 and then was reclassified as a dwarf planet in 2006. It was named by an 11-year-old girl from England called Venetia Burney, who was given £5 as a prize for proposing the winning name, and £5 was worth about £300 in those times. So it was actually a pretty decent prize. And in fact, Pluto or Pluton was the Roman god of wealth, as well as being the king of the underworld. So precious metals and gems come from underground. So maybe it makes sense that he would have been the guardian of valuable metals, instead of it just being a kind of a metaphor for money being evil or anything like that. The name Pluto comes from the Proto-Indo-European root word meaning to flow, and probably evolved into words meaning wealth and riches due to the concept of overflowing. Pluto actually has 5 moons, which I didn't know, the largest of which is Charon. Charon is about half the size of Pluto and is named after the Greek mythological ferryman who would ferry the dead across the river Styx to the underworld. Another of the moons is named Styx, while the others are named Nyx, after the Greek goddess of darkness and the mother of Charon. Kerberos, the 3-headed dog that guarded the Greek underworld. Hydra, the 9-headed serpent that battles Hercules in Greek mythology. Am I missing one? I think I'm missing one. We can come back to that. We've got Nyx, Styx, Nyx, Charon, Kerberos, and Hydra. Okay, we've got 5. That's good. So as a dwarf planet, Pluto is very, very, very small. Smaller than our moon, in fact. And it's also super, super cold on Pluto. It can reach minus 240 degrees Celsius on its surface. So you would be maybe feeling very sorry for Pluto right now, thinking it's a very cold, lonely life out there for poor little ex-planet Pluto. But actually, Pluto has plenty of new dwarf planet buddies out there. We don't know how many of them there are, but there are 3 that we've identified so far, called Eris, Huamea, and Makemake. So Eris is almost exactly the same size as Pluto and is named after the ancient Greek goddess of strife. Huamea and Makemake are even smaller than Pluto. Huamea is egg-shaped and is named after the Hawaiian goddess of childbirth, and Makemake is the god of fertility and the creator of humanity for the Rapa Nui people of Easter Island. There is also another dwarf planet which is quite near to us. Ceres lives in the asteroid belt, a region of space between Mars and Jupiter that is filled with rocky objects. And Ceres is named after the Roman goddess of bounty, which is great because there may well be bountiful new friends that we have yet to find in our solar system. Okay, so I'm going to move away from the planets now, expand into the wider universe. I have a few more space-related etymologies to talk about. First up, keeping to the theme of things that humans could see from Earth, I have constellation, which comes from 3 Latin words meaning together, star, and process. So ancient civilizations often kept track of different constellations by giving them names and memorable shapes, which they used to help them keep track of the year, as different constellations will be visible during different yearly events like the equinoxes, which will be important for scheduling various farming activities as well as other things. And actually, they ended up noticing that there were 12 or 13 constellations that would proceed through the sky in kind of a certain order, one after the other, that was always consistent, as if they were traveling on a great circle about the Earth. And today we call this great circle of constellations the zodiac, from the ancient Greece zodiacus kuklos, meaning circle of little animals, which is very cute. I'm not going to go into the etymologies of all of the zodiac constellations today, but some of them are quite interesting. So once humans had telescopes, we could start observing and naming things in the universe that we hadn't been able to resolve previously, like nebulae. Nebula comes to us from Latin, where it meant mist or cloud. And in its earliest English uses in the 1600s, nebula actually referred to a cloudy speck or film on the eye that caused vision problems. And it was first applied to great interstellar clouds of gas and dust in the early 1700s. And you can kind of imagine how this word could evolve from meaning a cloudy speck on the eye to a cloudy speck in a telescope, which would turn out to actually be a huge cloud of interstellar gas and dust. We also noticed that many of the bright specks in the night sky weren't single stars at all, but whole galaxies, just like our own, the Milky Way. And actually, the word galaxius in Latin was used to refer to the Milky Way itself and stems from the Greek words for milky, which is galaxius, and circle or cycle, which is kyklos. The Greek word galactos just means milk, I typed this into Google into Google Translate to check, and it's also the root of our word for the sugar that's found in milk, lactose. So this word itself stems from the Proto-Indo-European word for milk, which was galag, and this means that our word for all of the galaxies in the universe stems from the word that we first used to describe our own, which was milky. I think that's quite nice. Okay, so finally we have reached the end of our short trip through some of the words that we have used to describe the universe, and here is the grand finale, the word universe itself. So altogether, the word universe stems from the Latin word universus, meaning all things turned into one thing. And as you might guess, the word uni stems from the word meaning one unique. The second half of the word means turned into, from the original Proto-Indo-European word for turn or bend. And versus also means a line of writing, and the old French verse, as well as the English verse, means, a line of song or a section of a song. So universe might be translated as written into one or sung into one. And I think this is quite poetic, as humans have always kind of sought to describe and record the world that they see around them. And in some sense, I think that the word universe might also be kind of a nice word to use to describe the entirety of human language, as it records everything we know about everything that we've discovered and will discover as we evolve. So thank you very much for listening, and I hope you've enjoyed learning about the history of these space words as much as I have. And just to finish, I did write a book, as was mentioned at the beginning. It's called Etymology: Why Uranus is Not Called George and Other Facts About Space and Words. So if you enjoyed this talk, please consider maybe someone else in your life might like to read the book. I don't know, but yeah, okay, that's it from me. I'm happy to answer questions if anyone has any.
I want to know more about the book. That's cute.
Yeah?
Yeah.
Okay, this is the book. I've put the Amazon
link. How do you say that?
Planetomology.
Planetomology.
Yeah.
Why Uranus is not called George and Other Facts About Space and Words. Oh my gosh, that is so cool. That is really cool.
Yeah, so, and you can get it in hardback and also paperback and also as an ebook. Many options.
Well, if you can email me a link, I'll put it up on our Facebook page. I think
that's I will do.
Cool one. Yeah.
Awesome.
So we've got some people making some comments, but no questions. Here we go. Paul has noted that he thought Charon was pronounced Charon.
It may well be. I've heard many different versions of that, and I also will hasten to point out that I regularly pronounce things incorrectly. So,
don't worry. So do I. Chris will attest to that. Seeing if we've got any questions. Lots of we got. Everyone loved the presentation.
Thanks everyone.
Thank you for a beautiful presentation. It was really cool. The graphics were quite amazing. Did you do those graphics yourself, or?
Yes, I did.
They're cool. I really like them, especially poor little Pluto.
I know. I made him look so sad.
Poor sad Pluto. There we go. Someone wants me to post the book details in the chat. We will pop the book details in the chat. I think it's actually a really cute looking book. Might have to get one for my daughter. Here we go. We have a question. Whoops. Hang on. What about the perpetual universe as portrayed in Battlestar Galactica? Well, it all depends if you're a Battlestar Galactica fan. Do you know anything about that? I don't.
I don't. I'm so sorry.
I think Lee might have to go and research that one himself. Lots of people, fascinating talk. I think you've engaged with the viewers quite well.
Excellent. I'm really pleased.
Charming caricatures too. I agree. The little cartoon planets were beautiful.
Oh, thanks.
Oh, look at that. Noel's already put the book in there for you.
Oh, thank you.
So one of our members has already posted it for you.
Awesome.
Here we go. We have a question and you might be able to answer it. Wondering, is the Earth moving or not?
Yes, the Earth is moving.
In relationship to everything, really?
Yeah, it's difficult to define. You have to kind of define your reference frame, I suppose. which is a very physicsy answer, but the Earth is moving around the sun, and the sun is moving around the galaxy, and the galaxy is moving through the universe, and the universe itself is expanding. So everything's moving. But luckily, we're quite small and we're kind of stuck to the surface of the Earth with gravity. So from our very kind of limited perspective, it doesn't seem to be moving, but it is.
There we go. So I think we've covered off all of the questions. Chris, did you have anything else you wanted to add before we get Stefan going on his tour of the night sky? No.
Fascinating talk. Thoroughly enjoyed it. It was, as said, the graphics were terrific. And thank you so much for taking the time and the trouble to come and talk to us.
No problem at all. It's been a pleasure.
We do have a question for you. One last question.
Mm-hmm.
Renee Roberts wants to know, has your interest in the etymology deepened your knowledge of the planets?
It has, very much so, yes. I actually think that before I started researching this, I didn't really know which order the planets were in. But now I definitely know which order the planets are in, and I also know a lot more about the details of the planets themselves because I wrote a lot more about them in the book. Like I found out all of the things about the properties of the planets and the their kind of day lengths and that kind of thing, and yeah, the kind of properties of their moons as well. So I definitely have discovered many more things about the planets through this kind of avenue. And I think this is one of the reasons that this subject is quite engaging in the first place, is because it kind of spans multiple different subjects. And I always found the connections between these different subjects to be particularly interesting, and a good way to engage people with lots of different interests.
We've got another question. They're all starting to pop in now, all the questions. What do you think of the downgrading of Pluto? And at the time of Herschel, was there any reference to the Oort cloud?
Oh, I don't, on the last point, I don't know. On the first point, I think that the scientific designation of Pluto as a dwarf planet has got to be accepted because it's science. And also, well, I mean, maybe you could argue that if we accepted Pluto as a planet, then we would have to accept all of the other dwarf planets as planets. Yeah. But maybe that would be a good thing. I don't know. It would make it trickier to teach kids about that at school, I guess, if we had too many.
And I've always thought that we should actually characterise Pluto as a double planet.
I've heard that too.
With Charon, it goes around its... the barycenter is outside of Pluto.
Yeah.
So it is something quite unique and probably deserves more recognition than it gets.
Yeah, that's true. The reason that it's not a planet is because it hasn't cleared its orbit. So there are still kind of bits of debris hanging around in its orbit, which means that it's not classified as a planet, mainly because of that.
Now we've got another one here. Can you speak more on Vulcan, please?
Oh, I don't know a lot about Vulcan, but I do know that he was supposed to be just a hideous character. And it's very interesting, actually, that they decided that Venus, who was this kind of lovely goddess of love and everything that was beautiful and delightful, should be married to somebody absolutely repulsive and hideous and violent and aggressive and angry. It's very strange.
Now, I'm just going to try and stall a bit because Stefan's computer's just died on him.
Oh dear.
Yeah.
Well, we certainly wish you well for your for the defence of your PhD paper on Friday, and
thank you very much.
I'm sure that's probably giving you more nerves than talking to us.
Oh, absolutely. No, this has been a delight.
So we've got another one on Planet X. Anything about Planet X?
Oh, I love the topic of Planet X. So this is the fact that people have kind of observed a clustering of various bodies in the solar system that seems to sway them towards one particular location, and that suggests that there's some kind of additional gravitational force coming from something that we can't see, which suggests that there might be another planet, potentially Neptune-sized, I think I've heard mentioned, a very big planet, or at least very massive, hanging out at the very edge of the solar system, very, very far away, very, very distant, so we can't see it, and very, very cold as well. And recently there was a paper where some people proposed that Planet X is actually a black hole. I don't know whether that's true, but one of the best things about this paper was that they had a 2-scale diagram of the black hole in the paper, because the black hole would be so small that it would fit on an A4 sheet of paper. So they just had this black circle the size of the black hole, which I just love that. But yeah, Planet X is definitely an interesting subject.
Okay, so we've got. We'll pop one more question up while Stefan gets himself sorted again. Is there a study of the lesser-known names given to these things from other cultures? It would be interesting to read about other names for the same things and the stories behind those names.
Yeah, I absolutely would. I definitely agree with that. I always feel a bit like I'm really covering like a very limited and biased snapshot of this vast array of the different names. There are definitely people who have studied these things from the perspectives of lots of different cultures. I kind of just focused on these ones because these are the names that I grew up with. But it would definitely be really interesting to look at this kind of thing. Like finding the connections between the different cultures as well is really interesting, and it kind of tells us about how humans have kind of grown and evolved and spread out into different locations and potentially interacted with each other a lot more in the past, and that kind of thing. And things like, for example, I think there's one of the constellations, I think it's Orion. It's kind of a hunter in lots of different cultures all over the place, even in kind of traditional southern hemisphere tales, which is interesting because he appears upside down in the southern hemisphere. So that suggests that potentially that kind of story of Orion came from somewhere else in the first place.
And I think Stefan's ready now. So welcome to the stream, Stefan.
Ready.
And thank you, Isabel.
Thank you very much, Isabel. That was fantastic.
Yeah.
Thank you. I'm glad you enjoyed it.
Now, the floor is yours, Stefan, to give us a tour of the November night sky.
Perfect. So you see my screen?
Yes, we can. We can see your screen.
Do you see my screen? Do you hear me? Okay. Beautiful.
Yes.
Beautiful. Yep. All right. No problem. Yes. So I'll be going through what's in the sky for this November. So I'll start off within the solar system. And I should say as well that I'm primarily a photographer. So sorry if it's a bit photography biased. I've tried to include some more visual stuff this time. So starting off tonight, actually, there's a conjunction between Saturn and the Moon. They'll be separated by around 4 degrees. So this is a nice sort of separation to see with any low to mid-powered binoculars, or even to photograph with DSLR and even a simple stock lens. Anything around, they can get to around 300 millimeters focal length. You'll be able to frame the two of them quite nicely. I should also say that when photographing conjunctions like this, it's tempting to photograph them while they're nice and high so that you can get the best detail on the surface of the moon and the planet. But often it's actually much more aesthetically pleasing to image when it's closer to the horizon and you've got some foreground object to sort of give a bit of context and bring the two objects out a little bit more. So that's one thing to take into account. Then the next night, there'll be a conjunction between Jupiter and the Moon. They'll be a little bit further separated, around 5 degrees on the night sky, but still, again, perfect for low to mid-powered binoculars. You'll be able to see both of them in the same field of view. And again, with the same photographic setup, a DSLR with like a 300 to 400 millimeter focal length, set it up on a tripod, you'll be able to get a really beautiful photograph. A little bonus, the Great Red Spot will also be visible at this time on Jupiter, and the 4 Galilean moons are in a nice sort of spatial arrangement where they're sort of evenly spaced on this line. So a fantastic time to photograph, and if you can get enough detail that you can see the Great Red Spot and the moon in the same photograph, it'd be absolutely beautiful. Then early November, Uranus is actually at opposition, meaning it's at its closest point to us, or we're in our closest point to it in our orbit. And so this is the best time to get any photographs of Uranus. You'll find it towards the north. It only gets to around 37 degrees in altitude, but that's high enough to get a decent image. However, it's only magnitude 6.7, so you won't be able to see it with your naked eyes most likely, but you can probably with some low-powered binoculars, especially from darker skies. If you move up a step to a telescope, something like a 10-inch Newtonian reflector with a modest-sized eyepiece, you'll be able to resolve some of the disk of Uranus and possibly even see a couple of its brighter moons. If you include then magnifying Barlow into that setup, you'll easily be able to resolve the disk from the moons. However, at this magnification, you'll absolutely need a tracking mount. Otherwise, it's just going to zoom straight out of the field of view. This is the kind of field of view that you can expect with a modest planetary setup, something like a tracking Dobsonian or a 10-inch reflector on an equatorial mount with 5 times Barlow and any astronomy camera. You'll easily be able to detect the brighter moons, and if you photograph it over the course of a few hours, you'll be able to see Uranus and its moons moving in relation to the background stars. This can make a really beautiful animation. So the last little thing in our solar system, not a lot's happening at the moment, but one thing, Comet 67P Churyumov-Gerasimenko is at its closest point to Earth on November 12th. And you may remember this comet. It's actually a very special comet in human history. It's the first comet that we ever were able to land a robotic lander onto the core, onto the nucleus of the comet. This was back with the Rosetta mission back in 2014. And the lander was able to capture some really, really fascinating, beautiful photographs from the surface of the cometary nucleus. And I think it's interesting, we tend to see these images of these comets and think that they're just small boulders out there in space, but this really is, a large city-sized object out there that's part of our solar system. So, give it a go, try and photograph it, see what you can do. It's very, very dim, unfortunately, because it is very small and not very reflective. It's about a visual magnitude 13 at the moment in November, meaning that you'll want something with an aperture more than 4 inches and a relatively fast scope like a reflector in order to detect it at all. Again, dark skies are going to be better for this. And this is the kind of field of view you can expect with this same planetary setup. You'll be able to detect the core. You won't be able to resolve any detail. It's just far too small for that and too far away. And I'm not sure if at the moment there's any halo to the comet or any tail, but I guess we'll see as it develops over the next few days. So moving into the deep sky. So we're just moving out of our galaxy season into our summer season when Orion starts to rise in the eastern horizon. But I'll just finish off with some of the galaxies that we're slowly moving away from. So here on the right, I'll show the simulated field of view that you can expect with modest astrophotography equipment and the simulated field of view that you can expect with modest visual equipment. So NGC 253, I'm sure most of us know this galaxy. It's one of the most beautiful galaxies we see in the Southern Hemisphere. It's an intermediate spiral galaxy in the constellation Sculptor. And as you can see, we're seeing it almost edge on. So we see a lot of this really fine detail within the arms of the disk. It's located around 11.5 million light years away. It's relatively bright as galaxies go at magnitude 8, and it's one of the largest galaxies that we can see in the Southern Hemisphere, barring the Magellanic Clouds. In total length, it's almost half a degree in length, so it's a fantastic object image. You can get heaps of detail in the core, and especially if you also use a hydrogen alpha filter to bring out some of the red glow from the Emission Nebula embedded within the galaxy itself. So another similar yet slightly stranger looking galaxy, NGC 55, the String of Pearls galaxy. This is another barred irregular spiral galaxy in Sculptor. It's around 6.5 million light years away. It's a little bit dimmer at magnitude 8.8, but it's a relatively similar size as NGC 253. Another really beautiful galaxy to image. Again, use a hydrogen alpha filter if you've got it. Bring out some of the emission nebulosity embedded within. and you'll be able to see a lot of nice fine detail. Again, would be good in a modestly sized telescope, but of course for all of these deep sky objects you really need to be out in dark skies. NGC 300, the southern Pinwheel galaxy. This is another spiral galaxy, but this time we're seeing it almost face on. This is an unbarred spiral galaxy, meaning it lacks a bar in the galactic nucleus, again in the constellation Sculptor. It's around 6 million light years away, and it's a bit more dim still at magnitude 9.0. It's a little bit smaller in diameter than the other galaxies, in visual diameter as we see, not in actual diameter. And so it's a little bit more challenging to image, and because it's face on, its integrated magnitude is 9.0, but its surface brightness is really low, so you'll need a lot of total exposure time in order to bring it out properly. A little more challenging, but another fantastic target. And as you can see, there are a number of emission nebulae embedded within the spiral arms. It's a very active starburst galaxy, so another one that would really benefit from using hydrogen alpha filter. NGC 1365 and surrounding friends. There's a cluster of galaxies in the constellation Fornax, a bit further away, around 56 million light years away. As you can see, there's one prominent member here, NGC 1365. I believe it's called the Great Barred Spiral Galaxy, and you can probably figure out why. It's got a very prominent bar in these two beautiful spiral arms. But also surrounding in the same field are a number of galaxies. Someone I know recently photographed this, and we plate solved the image, and we could count, almost 150 galaxies that were detected within this one field of view. So it's a really beautiful region to image, even if the primary galaxy is a little bit smaller. The Large Magellanic Cloud, I'm sure I don't need to explain to anyone what this is. I'm sure all of us living in the Southern Hemisphere are well familiar with this. It's a dwarf irregular galaxy in the constellation Dorado, and it's one of our galactic neighbors. It's actually a satellite of our own Milky Way galaxy that's orbiting us and will eventually merge with the Milky Way. It's around 160,000 light years away, and it's incredibly bright, visual magnitude 0.7, meaning you can easily see it with the unaided naked eye from darker skies. Even in relatively dark suburban skies, you can see it. It's also incredibly large on the night sky, spanning over 10 degrees. And here I've put a full moon to scale with the galaxy, just so you can see that this is an absolutely enormous region. Because of this, you obviously can't see the entire galaxy if you use a telescope, so it's best seen using something like low to mid-powered binoculars. You'll be able to see the central bar of the galaxy and some of the extended nebulae around there. Again, darker skies, much better. This is the type of field of view that you can expect if you use a DSLR and a 100mm lens setup, a full-frame DSLR. This is a really great type of photograph to get, and because the equipment's fairly small and fairly light and small focal length, it's very, very forgiving to photograph. You can put this on a tracking mount like the Skywatcher Star Adventurer, or even a tripod, and take very short exposures and stack those. Beautiful, beautiful target to image. And of course, within the Large Magellanic Cloud and surrounding it, there are a number of really intricate, beautiful, bright nebulae. In particular, this bright one down here, the Tarantula Nebula. This is another famous southern object, of course. I'm sure all of us listening are probably familiar with this. It's an emission nebula embedded within the Large Magellanic Cloud, again, around 160,000 light years away. It's relatively bright as emission nebulae go, magnitude 8, and the core of the Tarantula Nebula is around almost a degree in size if you count the extended core around here. But of course, there's heaps of nebulosity, lots of complex nebulosity all over the place. There are even some supernovae remnants within this field. It's a fantastic region to photograph, and especially if you've got sulfur, hydrogen, oxygen filters, narrowband filters, you can image this and generate a Hubble palette image. Absolutely fantastic. And of course, beautiful, beautiful object to view as well. Our other galactic neighbor, the Small Magellanic Cloud, it's another dwarf irregular galaxy. This time we see it in the constellations Tucana and Hydrus. It's around 200,000 light years away and visual magnitude 2.7. It's a little dimmer than the Large Magellanic Cloud, a little smaller, of course, as the name implies, but it's still a fantastic region to view visually and photograph. Again, there's a large amount of hydrogen nebulosity embedded within the galaxy itself, and in particular, I'm pointing out here these two nebulae here, which is NGC 346 and a few other nebulae. And these are actually very, very high energy emission nebulae. They're giving birth to very large, very high energy stars within their core, which are then in turn illuminating the nebulosity surrounding them. And the energy that's being output here is high enough that there's a lot of oxygen-3 emission. And so when you photograph these nebulae, they come out really beautiful and blue, the core of them, with a lot of red hydrogen nebulosity surrounding it. So it's a fantastic region to photograph for beginners and also more advanced photographers. So moving on now to some of the more summer constellations. Of course, if you've been out at night recently, like I have, you'll see earlier in the morning, the Orion Nebula is starting, the Orion constellation rather, is starting to peak over the horizon. And with that are, of course, all of the famous nebulae embedded within the Orion constellation. Of course, the crowd favorite M42, the Great Orion Nebula. This is the crown jewel of the Orion constellation, and I'm sure everyone who's ever been interested in astronomy is well familiar with this nebula. It's one of the biggest and brightest nebulae that we can see in the night sky. It's visible in both the northern and southern hemisphere. It's around 1,350 light years away, magnitude 4.0, incredibly bright. You can pretty much even see the core with your unaided naked eye if you know where you're looking. And it's pretty large as well, spanning around 1 degree for the entire region. Of course, this is probably the first nebula that everyone tries to see and everyone tries to photograph. And so it's a great nebula for beginners to photograph, but it's also a great nebula for more advanced photographers. And this is because there's a lot of this dim, extended nebulosity all the way out here. And then the core, of course, is incredibly bright. So it can be quite a challenge to image this nebula with enough dynamic range to preserve both the extended dim nebulosity and the incredibly bright core. So if you photographed this a few years ago when you started, have a think about returning to it and trying to pull out some of the more often lost details within the bright core. Another iconic nebula in Orion, the Horsehead Nebula. This is another Emission Nebula, of course, in Orion, around 1,370 light years away. The Horsehead itself, this little absorption nebula, is a little bit smaller, but the extended emission spans some 1 degree on the night sky again. Fantastic region to photograph. Of course, there's a lot of red hydrogen nebulosity, but there's also a lot of a few different embedded reflection nebulae that reflect this gorgeous blue. And the Flame Nebula up here, which is a brilliant sort of white brownish, a lot of really bizarre looking formations within this region. And again, another beautiful object to view visually from dark skies. I had the pleasure of looking at the Horsehead itself through our 40-inch telescope last summer, and I was amazed. I didn't think you could even see something, see an absorption nebula like this, but I could absolutely make out the structure of the Horsehead itself, contrasting with the background. It's absolutely spectacular. So if this is something that you'd like to see with your own eyes, please become a member if you're not, and come visit us up at the Leon Dark Sky site. So Msm M78, this is another emission/reflection nebula in the constellation Orion. Both, Orion, the Horsehead Nebula, and M78 are actually relatively close to each other. So if you've got something with a wide enough field of view, you can photograph all three of them at the same time. So this one, again, similar distance, it's 1,350 light years away, but it's a fair bit dimmer. It's relatively large. It's 1 degree in length by half a degree in width, but you really need to get to dark skies and image this with LRGB in order to bring out some of the absorption nebulosity in this region. It's relatively dim, but a really beautiful, intricately colored and dynamic region that I think is pretty under-photographed. I see 1909, the Witchhead Nebula. This is another really famous nebula. It's one of these nebulae where its name actually suits the object. It really does look like a witch's head. If you've never seen it before, this is sort of the chin, the mouth, the nose, and the eye. And it really does look like a witch. It's one that actually lives up to its name. So this is a reflection nebula in the constellation Orion, and it's actually reflecting light from the really, really bright star Rigel here. It's magnitude 13, the nebula itself, which means it's incredibly, incredibly dim. It's not an emission nebula, so it's not putting out any of its own light. It's a reflection nebula, just reflecting light. So you really need to be at dark skies and using very sensitive cameras and fairly fast telescopes in order to bring out a lot of this detail. It's actually really quite large as well. As you can see here, I've actually got a mosaic of 2 images using the same setup in order to frame just the chin up to the eye. But it's a spectacular, beautiful object. It's quite a unique object as well. A lot of these nebulae that we photograph and view are emission nebulae, so they all sort of come out that typical emission nebula red pinkish color. But this one has a sort of really nice, brilliant blue and whitish tinge to it. Moving on to a couple of challenging targets for the advanced photographers out there. In the same field of view in Orion, there's this really beautiful sort of diffuse emission reflection nebula here that I've been planning on imaging, but haven't gotten around to it yet. It's a really, really fantastic region. It's called Sharpless 278. It's sort of this almost mountain-looking structure, this beautiful peak with this absorption nebula, some emission on the sides, and some reflection surrounding as well. Again, it's incredibly, incredibly dim. I couldn't find much information about this in terms of its magnitude, size, or distance, which just goes to show how challenging a target it really is. But I've seen recently, I think Anne-Marie, a member of our group and one of the more prominent astrophotographers, took an image of this and definitely did it justice. So if you're looking to photograph an object which isn't really seen much and isn't really photographed much, have a look at this one. I've just put this here for a frame of reference as to its size. There's not really any chance that you'd be able to see any of the structure of this nebula, at least with easily available equipment. The final and probably most challenging object is SH2, Sharpless 308. This is known as the Dolphin Head Nebula, another one that really lives up to its name. As I hope you can see, it really does look like a head with a dolphin's beak and this sort of smile, and its little eye in the center. I think it's one of the most beautiful looking nebulae I've seen. So this is actually an emission nebula surrounding a Wolf-Rayet star, this star in the center, which is a very large, powerful star that's nearing the end of its life. It's probably going to explode in a supernova, but before this happens, it's been shedding some of its outer layers, which is what's formed this beautiful emission bubble here. It's around 4,500 light years away in the constellation Canis Major, and it's around half a degree in size, so essentially the same size as the full moon on the night sky, but it is unbelievably dim. As you can see here in the simulated field of view, this was these simulated field of views that I've shown are based on survey data by the Deep Sky Survey, which is a professional observatory. And as you can see, you can barely make out a hint of it in this professional survey. really goes to show just how dim it is. And I tried photographing this nebula a couple of years back, and even with my very fast f2.8 telescope and 15 hours of total exposure, I really wasn't satisfied with the result. It's a really, really big challenge, but as you can see, if you can pull it off, it's a fantastic image. It really gives that sort of three-dimensionality to the object. And with that, I'll say thank you for listening and clear skies.
Thank you for a wonderful tour, Stefan. There was something in there for everyone, I think.
Thank you.
And the Dolphin Nebula, I see a little toy duck in there as well, inside the dolphin's mouth. I'm gonna have to
Very
mark
creative.
that one up.
I like that. You'll have to rename it.
I rename everything.
Thank you, Stefan. That was very good. I'm sure that some people have been buying far too much new equipment, looking at the skies outside and the skies that we're expecting over the next few days. We have to blame somebody, and
blame me.
Yeah,
buying
exactly. It. Yeah.
Oh, it's you.
It's me.
Really?
Yeah, it's my fault this time.
I'll speak to you later.
Now, before we go, I just want to mention that we have our Christmas barbecue raffle on sale at the moment, and the prize kit is probably one of the best prize kits we've had. It's an Ioctron CEM 26B equatorial balance mount with stainless steel tripod, a Skywatcher Evo Star 72 ED, a Skywatcher 0.85 times focal reducer for the ED72, 12-volt power supply, sidereal trading M48 T-mount for either a Canon or a Nikon, and the raffle value is $3,124. Includes delivery, and it's fully insured delivery as well. All the funds raised from our raffle will go towards our All Abilities project, which is roaring along at a rate of knots at the moment, isn't it, Chris?
It certainly is.
We've got pathways nearing or getting close to getting laid. We've got the location set out for the All Abilities roll-off astronomy shed, and the scope is well underway as well. In fact, it might well be ready for us for our barbecue. The raffle will be drawn on the barbecue, which unfortunately this year is members only because of the current situation. It's a little bit easier for us as volunteers to manage. So it'll be drawn at the 11th of December at 7 p.m. So if you haven't got your tickets, links on I believe should be on the ASV website. If it's not, it'll be there soon. It's on our Facebook page as well. If you haven't got a ticket, grab one. And once again, thank you for joining us for our AstroTalk. We hope you enjoyed the stream. And if you're not yet a member and interested in seeing Horsehead Nebula through the 40-inch, as Stefan said, I agree. I've seen it. It's amazing. Become a member, www.asv.org.au/join. If you don't follow us on Facebook, please do, and please hit the subscribe button on YouTube as well. Until next time, clear skies.
Good night.